So good day, everyone. So the next aspect of organic or reaction mechanism that we are going to treat is carbanion. If you could still remember, as in my previous video, I said the reaction mechanism, it tells us the what? The actual pathway of the what? Of the reaction. And I said any reaction, for any what reaction, we have reactants, or let me call it what? Substrates. For we have what? Reactants, then it will give us what? Products. But the reactant is comprised of what we call what? Substrate plus reagent. And it will give us what? Products. So, but if we want to show the mechanism of what? Of this reaction, in the mechanism of reaction, we will have what? Substrate plus reagent. It will lead to the what we call what? Reaction intermediate. Reaction what? Intermediate. The reaction intermediate, it will lead to what we call what? Product. And I said the reaction intermediate is a short lifetime, is a short life fragment. The short what? Life fragment, and which is what? Unstable, and they are highly reactive, is comprised of three things. The first one, I said we have carbonium ion. The second one, I said we have carbanion. The third one, I said we have free what? Radicals. So all organic reaction has three reaction intermediate. It may be what? Carbonium ion, carbanion, or free what? Free radical. So in my last class, I've explained carbonium ion. I said carbonium ion is a organic carbon with positive what? Positive charge. Organic carbon atom or organic compound that has a negatively what? Carbon charge is called carbonium ion. But this free radical is organic carbon atom or organic compound or reagent without what? Positive or negative, which is what? Is neutral. And they are unstable, like carbonium ion and the carbanion. They are what? Unstable. And they are also what? And they are also have highly reactive property. And this carbonium ion and carbanion, I said, both of them, they are the product of what? Of homolytic fission. No, heterolytic. Heterolytic what? Fission can lead to this, but the homolytic fission can give us what? Can give us free radicals. So in today's class now, we are going to treat what? Carbanion. Carbon what? Carbanion. What is carbanion? It's an organic compound which contains a negatively charged carbon atom. This is what? This is an organic compound organic what? Compound. This organic what? Compound atom, which contain a negatively charged carbon atom, and there are products or let me use what? They are formed. They are what? Formed by heterolytic fission. Heterolytic bond fission. Let me complete it. Bond what? Bond fission. That is what? Carbon what? Carbanion is an organic compound that is have what? Carbon negatively what? Charge. Due to the what? The heterolytic bond fission that occur. Take for instance, if you have a compound, have organic compound of, we have carbon bond with Z like this. So in this case, if this carbon is more electronegative than Z, the bond electron here will shift. The bond electron here will what? Will shift. Sorry, the marker is not. The bond electron here is what? It shifts to what? To carbon. In this scenario, the carbon is more electronegative than what? Than Z. So what do we have? In this reaction, we are going to what? Have this at the product side, carbon, 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 and we have what? A negative charge. So the Z will become a positive what? Charge. This carbon here is called carbanion. So this is what we call what? Carbon what? Carbanion, which is formed as a result of what? Of heterolytic bond fission, which occur between the carbon and the what? And the Z. And the carbon is more electronegative than what? Than Z. That is a carbanion, which is a product of heterolytic fission. And the carbanion can be named, the nomenclature for the carbanion is same thing as what? If you have this idea, if you have a CH3, C what? H3 minus. So the charge of this CH3 is what? Is minus. The name of compound, we call it what? Methyl carbanion. But if we have in this form CH3, we have CH2, and the charge on this carbon is what? Is negative. We call it what? Ethyl carbanion. Likewise, if we have a what? A compound of CH3, CH2, CH2, and we have what? Our carbon here is what? Negative. So the compound, we call it what? Will be carbanion. So the same thing if we have what? CH3, CH2, CH2, CH2. This compound is what? Is negative. What do we call it? Can call it what? Butyl carbanion. So that's how we name what? Carbon what? Carbanion. And the next thing of carbanion that I would like to treat is what? Formation of carbanion. Let's look at how what carbanion form. Then formation of carbanion. You know that what carbanion is an organic compound with carbon that carry a negative what? Charge. So how carbanion form? The carbanion form, or let me say organic what? Organic compounds having acidic hydrogen. Acidic what? Hydrogen have the tendency, have the what? The tendency to produce carbanion. Have the tendency to produce what? Carbanion. Organic compound with what? Having acidic hydrogen have the tendency to produce what? Carbanion. If you look at one, let me use this as a case of study. Okay, case of study, we have carbon with acidic hydrogen, HH. If this is acidic hydrogen, basically this carbon here is what? Is more acidic than what? Than this. Is more acidic than hydrogen, and the bond electron will shift to this side. So when shift to that side, we are going to have what? We are going to have C bonds, and the bond here plus this. So the bond we have on this carbon will become what? Yes, it will become a negative charge. It will become a negative what? Charge. And the bond on this hydrogen will become a positive charge. And this carbon is called carbon what? Carbanion. Or do it in this way. Let me take a what? A hydrocarbon that have acidic hydrogen. This is what? Ethyl. Ethyl or any terminal what? Alkyne. This is what? Ethyl. So this ethyl is what? It has acidic what? Hydrogen in front. So when this ethyl ionize or release its acidic hydrogen, it's going to give us what? C triple bond C plus H. And the carbon here will be what? Negative, H is positive. This is what we call what? A what? Ethyl carbanion. So that is how what carbanion form. The next aspect of carbanion I'm going to explain now is stability of what? Of carbanion. If you look at stability of carbanion, the stability of carbanion, the stability of carbanion can also be explained or can also be influenced by two things. What are they? We have what called inductive effect, and we also have what resonance effect. Can be explained by what? Resonance effect, and the other one can be explained by what? Inductive what? Effect. So those are the two things that we can use to what? To explain the stability of carbanion. We have resonance effect and we have inductive what? Effect. Take for instance, for example, for example, let me say what? For what? For example, yes. For example, benzyl carbanion, benzyl carbanion is much more stable than propylcarbanion. Is more stable than what? Propyl what? Carbanion. The benzyl carbanion is more stable than what? Propyl what? Carbanion. Let me draw the structure of benzyl carbanion. This benzyl carbanion is CH3. We have benzene like this. Yes. No, here we have CH2. And on top of this what? We have negative charge here. This is the what? Benzene what? Carbanion. But this propylcarbanion, this is own structure CH3, CH2, CH2, negative what? Charge. This is the what? Propylcarbanion. So this benzene carbanion is more stable than propylcarbanion. Why? Because this benzene carbanion undergo resonance, and this propylcarbanion cannot undergo resonance. You know the reason? Resonance occur here. Resonance occur what? Occur here. And here we have what? No resonance. So the presence of the resonance in this compound is make this benzene carbanion more stable than what? Than propylcarbanion. So what are the resonance structure for this? Let me show you the resonance that this structure is what? Is exhibit. We have C2, we have benzene. This is what? Benzene ring of this structure. Good. Look at this structure now. And the charge here is what? Is negative. So the shifting of this what? This negative charge to this side, and shifting of this pi bond from here to this end If that happen, this will become CH2 instead of single bond. This come it will become what? A double bond on the benzene, and we have our benzene ring in this what? In this form. This is the main structure of what? Of the benzene. This one remain here. This pi bond come to this side, so we have it here. Good. So as minus, we have this here. So the next thing that we do here is what? This negative charge we have here, it's unstable, it will come back to this side. When this come back to this side, this pi bond will come towards to this side. So between this, we have a reversible reaction. Yes, we have a reversible reaction. You will now observe that what? This CH2 remain here, the double bond, we have what? This is come to this side, it will become double bond. Here, this come to this side, it will become a what? The negative charge, and this is what is here. And the next thing that is to happen is what? The negative charge will come to this side, and this one will also come to this side. So to add the last what? Resonance structure. So you can now have what? The CH2 double bond, this to give you this, and we have what? This is here, and the bond here will come to this side. This one will come to what? To the side. So how many resonance structure does benzene carbonium ion has? It's 4. The tendency of this to have this kind of structure is making to what? To more stable than propyl-carbanion. So the propyl-carbanion cannot undergo what? The resonance structure. And more also, the stability of carbanion can also be explained by inductive what? Inductive effects. But this is what stability explained by what? By resonance. The stability of carbanion can also be explained, like I said, by inductive what? Effects. So the like you know this everything we have in carbanion, we also have it in carbonium ion. The carbanion, now I said is what? Is a carbon with what? Negative what? Negative charge. Abi? So, but I've explained carbonium ion, a carbon with positive charge. I mean, so and I use what? Inductive effect to explain is what? Its own stability too. So the stability of carbanion is the opposite side of what? Of stability of what? Of carbonium ion by inductive what? Effect. So by using inductive effect to explain the stability of carbanion, so now we start from where this, if you have a carbon H, 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 this, and I put what? A negative charge here. This is methyl what? Carbanion. We call it what? Methyl carbon what? Carbanion. But in case of we have what? C H H, and we have one R here, then in front here there is a what? A negative charge. The same thing if we have what? A carbon, we have H here, and here we have R, here we have a key group. And we know that what this alkyl group is a electron releasing group. Alkyl group, they are electron what? Releasing group. So here we have what? Negative charge. You have to make it carbanion. And here we have R alkyl. We also have another R alkyl. We also have what? Another what? R and what? Alkyl group. And here we also have what? Negative carbanion, negative charge. So this is what we call what? Primary carbanion. This is what? Secondary carbanion. This is the tertiary carbanion. In terms of their stability, this ordinary metal carbanion is more stable than primary. Primary more stable than secondary. Secondary more stable than what? Tertiary. This is what? The decrease in what? Stability. Decrease in stability of carbanion. But if it is carbon positive charge, carbonium ion, this one is what? It will be more stable. So that is all about what? Carbanion. So let me treat the last aspect of reaction intermediate, which is what? Carbon free radicals.